In this video, we're going to discuss double replacement reactions. Double replacement reactions are when two compounds react by rearranging the positive ions. So in this example, you can see that A combines with D and then C combines with B. When you write your double replacement reaction, the positive ion or the cation is always first. The cation, which is positive, is always first in the formula for the compound. Okay, so double replacement reactions occur when the positive ions trade places, which we were just saying, in order to form two new substances, one of which is a solid, which we call the precipitate. So a precipitate is a solid which forms as a result of two aqueous or clear solutions reacting. Spectator ions are the ions which are not involved in forming the solid. You can imagine them as like spectators at a game, right? They are just watching the reaction happen. We also have what's called the net ionic reaction, which is the reaction which is actually occurring. And we'll be talking about that more in the next video. And we know that a compound is a precipitate or not by using our solubility rules, which are in your reference packet. So if you don't have your reference packet out, you should pause now and go get it. So first we're going to talk about how to interpret the solubility rules. So we're going to write soluble or insoluble next to each of these compounds by using our rules. So again, in your reference packet, you should see this chart here. It's at the top of one of the pages in your reference packet. Now, soluble means able to dissolve. Insoluble means it's not able to dissolve. So something is insoluble, we say that it's a solid. If something is soluble, we say that it is aqueous, which means dissolved in water. Okay? So in this first one, potassium bromide, this says, the first rule says all nitrates, acetates, ammonium, and group 1 salts are soluble. Group 1 is referring to all the metals in group 1. This idea of salts just means that it's an ionic compound. Okay. So that means any compound made with a group 1 metal will be soluble. So in A, potassium is in group 1, and so this would be a soluble compound, which means we would say that it was aqueous or able to dissolve. All right, so this one, B, we have lead carbonate. Now you'll notice that most of the rules start off with negative ions or anions. So over here we see a carbonate rule, right? So all carbonates and phosphates are insoluble. Now it says except group 1 and ammonium, because that refers back to this first rule that we talked about in the last example. So since all carbonates are insoluble except group 1, and lead is not in group 1, it's in group 4, so that makes this insoluble. And so if it's insoluble, it would be a solid or the precipitate if it were formed. All right, for letter C, we have zinc hydroxide. So we find a rule for hydroxide. Here it says all hydroxides, again, are insoluble. Now there are some exceptions, of course, our group 1. And then it says strontium and barium and ammonium. But zinc is not in that list, so that makes this insoluble and would be a solid. All right, so next, sodium acetate. So again, we find our rules, right? It says all acetates are soluble, and there are no exceptions to that rule. So this would be a soluble compound. We also know that it's soluble because sodium's in group 1. So it just is very soluble in water. All right, next we have silver iodide. So we look through our rules and we find a rule that says iodides. Here's one. Iodides are soluble except for silver. So silver is an exception to being soluble. So that means it is not soluble. So it is insoluble and would therefore be a precipitate or the solid. All right, so our last example, cadmium 2 sulfide. So we find a rule for sulfides. Find it over here on the right. All sulfides are insoluble except group 1 and group 2. So we find cadmium. It's in the transition metal section, so it is not in group 1 or 2. So that means it would indeed still be insoluble. And we would say that it is a solid. Okay. All right, next, so let's look at writing these equations out. So precipitation reactions are nothing more than double replacement reactions. Right, we already talked about how double replacement reactions work. We're going to do a couple of practice problems. So the first thing we want to do is to determine whether or not we really need to write a reaction. So we can figure this out by rearranging these ions, right? So remember, double replacement reactions, your positive ions trade partners. So first we have iron 3 chloride and sodium hydroxide. So if our positive ions change partners, right, that'd be the iron and the sodium getting new partners. Iron would combine with hydroxide. So we'd have iron 3 hydroxide. And sodium would then combine with chloride. Okay. So then we want to determine, will a precipitate form? Because if both products are soluble, then no reaction will happen. So we don't need to write one. So we look at our rules. We find a rule for hydroxides. So all hydroxides are insoluble except for group 1, strontium, barium, ammonium. Iron is not in group 1. So that means this will be insoluble and will be our solid precipitate. So that means this reaction does work, and therefore we do need to write it out. So let's do our balanced equation. So first we have to write the formulas for all of our compounds correctly. So we have iron. Since this is 3, that means it's plus 3. We know that chloride is minus 1. They all have to add to 0 still, so we have to multiply the chloride charge by 3. So we would have 3 chlorides plus our sodium hydroxide. So sodium's in group 1, so that's plus 1. Hydroxide is one of our polyatomic ions. So if we look it up, its charge is minus 1. So those do add to 0, so it would be 1 of each, NaNO3. And then iron 3 hydroxide. Again, that 3 means that iron is plus 3. And hydroxide, we said before, was minus 1. So that's OH. And since it's minus 1, I have to multiply it by 3. So I'm going to have to put parentheses 3. And since that is my precipitate, I'm also going to put an S next to it to indicate that's my solid. And then sodium, again, is in group 1, so it's plus 1. And we said before, chloride's minus 1, so they already add to 0, so just 1 of each, NaCl. And of course, our final step then is to balance. So we want to start with iron, so 1 here and 1 over there, so that's good. Chlorines, so I have 3 chlorines here, but only 1 there, so I have to multiply here by 3. That gives me 3 sodiums, so on the left side I have to multiply over here by 3. So now I have 3 sodiums, but I also have, I wrote nitrate, that's hydroxide. What was I doing? I said hydroxide. Sorry about that. OH is hydroxide. Try that again. That makes 3 OHs, right? And 3 OHs here. So then it's balanced. Right? Next one. Magnesium sulfate and potassium phosphate. So again, it's good to just determine if the reaction will happen first. So magnesium will get a new partner. So it'll be magnesium phosphate and potassium will get a new partner, which will be sulfate. So then we look to see, will this form any products? Will we get a precipitate? So we come down here, we look at our rules, and we find our rule for phosphates. Phosphates are insoluble except group 1, strontium, barium, and ammonium. Oh no, sorry, except for group 1 and ammonium. So magnesium is in group 2, so that means this would be our solid precipitate. So that means we do have to write our reaction. So again, we look up our charges. Since magnesium is in group 2, it'd be a +2. And sulfate, that's a polyatomic ion, SO4, and its charge is -2. And so that adds to 0. And so that's the formula. And so then potassium phosphate, potassium's in group 1, so that'd be +1. Phosphate's a polyatomic ion, and it has a -3 charge. That does not equal 0, so we'd have to multiply potassium times 3. So we'd have 3 potassiums and then 1 phosphate, which is PO4. So then our products, again, we said magnesium was +2 and phosphate is -3. So that's 2 and that's 3. To make those add to 0, we make them 6, so 3 and 2. Right? So we get 3 magnesiums, Mg3, and then 2 phosphates, PO4, 2. And that is our solid precipitate, so we'll put S next to it. And then we get potassium sulfate. So again, potassium we said was +1, and sulfate we said was -2. So those don't equal 0, so we'd have to multiply potassium times 2. And so we get K2SO4. And then we can balance our equation. Start with our magnesium, 1 here, 3 there, so I have to multiply by 3. That 3 also goes to sulfate, so I have 3 SO4s. Over here I have only 1 SO4, so I'd multiply by 3. That makes 6 potassiums. On the left I have 3, so I'd have to multiply by 2. Now I have 6 potassiums. And then I have 2 phosphates, but over here I already have 2 phosphates. So then we are finished. All right, let's do another one. Copper 2 nitrate and calcium hydroxide. So if I make new partners, I'm going to get copper 2 hydroxide and calcium nitrate. Okay. So then we look to see, will this form a precipitate? So we look at our rules. We have a hydroxide. So hydroxides are insoluble except for group 1, strontium and barium. So copper is not in group 1. So that will be our solid precipitate. So then we want to write our reaction. So we have to write our formulas correctly using our charges. So here we have copper 2. That tells me copper is +2. Nitrate is a polyatomic ion. It's -1. So those do not equal 0, so I have to multiply by 2. So I need 2 nitrates and 1 copper. So Cu, put nitrate in parentheses, and then a 2. Plus our calcium hydroxide. Calcium, we find it on the periodic tables in group 2, so that's +2. Hydroxide is a polyatomic ion, and it's -1. Since those do not add to 0, we would multiply by 2 so that they do. And then we write our formula, Ca, I have 1 of those, and then I need 2 hydroxides, so put it in parentheses and the 2 outside. All right, so now our products. Copper 2, again, that's a +2 because of the 2. Hydroxide we said was -1. To make those add to 0, we'd have to multiply here by 2. So we get 1 Cu and 2 hydroxides. And since that's my solid, I'm going to write an S next to it. And then we have calcium nitrate. So calcium, as before, was in group 2, so that's +2. Nitrate's a -1 that we said before. Those don't equal 0, so I have to multiply the nitrate times 2. So then we get Ca, and then in parentheses, NO3 with a 2 outside. And then we balance our equation. So we have 1 copper here, 1 copper there. That's good. 2 nitrates here, 2 nitrates there. That's good. 1 calcium here, 1 calcium there, and then 2 hydroxides and 2 hydroxides. So this one is already balanced.